In Book 11 though, 7.4 types of solutions revisited. So remember that there are three types of solutions that quadratic equations can have. Sorry, I need to change something real quick, so in case I mess up. And those three types of solutions would be, we could have two solutions, right? That would be something that looks like this. We could have one solution. That would be if you had a quadratic that just touched. And we could have zero solutions. Let's put that over here, sorry. And that would be a quadratic that doesn't touch at all. Okay. Well, there is a way to figure out what happens in terms of zero solutions, one or two, without having to solve the quadratic the whole way. And that really has to do with the quadratic equation. And so if I look at the quadratic equation, the number of solutions is completely determined by b squared minus 4ac. Because if b squared minus 4ac is a number that comes out like we would expect usually, which is a positive number, so if we get a square root, for example the square root of 8 there, we end up with two solutions, right? Now in this case that wouldn't be nice, but you know, we'd still end up with two solutions. If you ended up underneath the square root with a plus or minus square root of 0, then that would disappear, and then the only thing that you have left is a solution at a negative b over 2a, which would be what we would call the vertex of the quadratic. And if we ended up with b squared minus 4ac as a negative number, for example a negative 8, then we don't have any real solutions, so we wouldn't have an intercept. And that means that if I just wanted to tell you what type of solutions we have, I can just look at b squared minus 4ac, which is called the discriminant. Sorry. So the discriminant allows you to look at how many solutions we have and actually what the type is. So how does that work? Well, if I look at x squared plus 5x minus 3 equals 0, and I want to know what the type of solution is, then I can just look at b squared minus 4ac. So b would be 5, so this would be 25 minus 4a here is 1, right? 4 times 1 times a negative 3, and I get 25, 4 times 3 is 12, that becomes a plus 12, and 25 plus 12 is 37. So in this case, 37 means I will have two solutions. And actually, because 37 does not end up with a square root that we actually know that two solutions, and they will be irrational. Okay, and the type in this case is actually irrational, because plus or minus the square root of 37 is, we're not sure what that is. Okay? If I look at this one, I'm going to do the same thing. I will have to make sure that I write this with a plus 20 over here, because b squared is still at 5, so I do get 5 squared minus 4 times a times c. I need to make sure that this 20 becomes positive when I use it. So this is 25 minus 80, which is a negative, right? Negative 55. So if I put that underneath the square root, I would be with an imaginary number. So we would say that there are 0 real, and I forgot the word real last time, solutions. Okay, so how about this one? It's probably the last one, right? So hopefully I did my math right. So let's see. So a negative b squared, or sorry, not a negative b squared, just b squared. So b squared minus 4ac. So 12 squared, which is 144, minus 4 times a is 4, and that's 9. So 144 minus 4 times 4 is 16 times 9 is 90 plus 54, which is 144 as well. So we get 0. So we would have one solution. Okay? All right. Let's move on. So that means that the discriminant is b squared minus 4ac. Okay, and it allows us to determine the number, and actually the type as well, the number and type of solutions. Okay, those problems are often in context of a slightly more difficult problem, which you're going to see here. So given this long equation over here, okay, and k can equal a -1, we need to show that the discriminant is given by this thing over here. So this little triangle here, that's the Brooks notation for discriminant. So that's the discriminant symbol. I will usually spell that out for you, so, but the book may not. All right, sorry about that. People are working. Well, the first thing we need to do is we actually need to multiply that k out. So we can kx squared plus 3kx plus 2k. And the reason for that is because we have a square here and that needs to line up with this square. So we need to have those together. So I got those done. So plus bk, or sorry, bx plus 3kx. So I got that one done, and then I have 2k minus 2. So I have all the terms lined up. So I'm going to factor things out. So the x squared usually has the a in front of it. That's a little unclear. So x squared divided by itself would leave you 1 plus k. So that's our a. And then here we get bx plus 3kx. So if I take the x out, I have b plus 3k times x. And then this one is just our constant. So in terms of what we have here is a, b, and all of this is c. Now we're going to plug that into the discriminant, right? So b squared minus 4ac. So the discriminant, and I'm just going to use a capital D, would be b plus 3k squared minus 4 times 1 plus k times c, which is 2k minus 2. Multiply that out, so that's b squared plus 3kb twice, so that is 6kb, minus, and I need to do this one first, so that's 2k minus 2 plus 2k squared minus 2k. So I distribute it, right? So 1 times 2k, 1 times a -2, k times 2k, then a -2. Now I can multiply that -4 in. So b squared plus 6kb minus, 2k minus 2k cancels, so I can eliminate that. So I'm going to get -4 times -2 is +8, and -4 times a +2 is a -8k squared. And then I realized, as I was talking, I forgot something here. So I need to go back. Let me go back to over here. Sometimes I make mistakes too. So we'll do this one more time. Okay, so I do get b squared plus 6 3k squared, so that is 9k squared minus 4. And then I get the same thing back here, so that's still 2k minus 2 plus 2k squared minus 2k. This one cancels with that one, so b squared plus 6kb plus 9k squared minus 4 times a -2 is +8 minus 8k squared. So this one subtracts from that one. So I get b squared plus 6kb plus 1k squared plus 8, and that is exactly what I was supposed to get. So that's good. All right, then finally it says B, it says if b is 0, discuss the nature of the roots. So this is the discriminant. Okay, so we're going to plug in b as 0, so we will get 0 plus 6 times b is 0 plus k squared plus 8. So the discriminant is just going to be given by k squared plus 8. Well, the nature of the root means this. Am I going to get two solutions, 1 or 0? And you might wonder, well, how would you know? Well, since k is squared, k is always positive. So not a lot of stuff can happen. The smallest number you can square and get is 0, because 0 squared is 0. So k squared plus 8 is always at least 8, which is a positive number. So I'm going to get a discriminant which is greater than or equal to 8. So I will always have two solutions. Okay, and you might be thinking, well, what about a negative number, like a negative 3? Well, if you square a negative 3, don't we get positive still? So k squared plus 8 would be 9 plus 8 is 17. So you will always get a positive number there. So the nature of the roots is that you will always have two solutions if b is 0. Well, if b is 2, then we need to plug that in, right? So we're going to do 2 squared plus 6k times 2 plus k squared plus 8. 2 squared is 4, and 4 plus 8 is 12. So I'm going to rewrite this though. So I'm going to say, well, let's do this like k squared plus 12k plus 4 plus 8 is also 12. And I need to find the values for k for which the roots are equal. So the roots are equal. That really means we have the same solution twice. So this means we have one solution. So equal roots is another way of saying one solution. And that only happens if the discriminant is 0. So we need to solve this for 0. Well, I'm going to complete the square on here because it is a nice even number here, and 6 squared is 36. So to balance it out, so take the square root, so I would get, take the square root, I would get k plus 6 is equal to plus or minus the square root of 24. So k would be a negative 6 plus or minus 4 times 6, so 2 squared is 6. So we will have one solution if k is either a negative 6 minus 2 square root of 6, or if k is equal to negative 6 plus 2 square root of 6. That would be one solution. Okay? Thanks.